Hello everyone, my name is Steve and welcome to my Atari YouTube channel. For those of you who may not know, this channel can help you learn how to program an Atari computer in both basic and assembly language. I've been doing several different tutorials, but I've kind of slowed down a little bit here, guys, so for those who've been watching, bear with me on that for a moment. Going through a lot of transition in my life. I've started a new job that's been a couple weeks now. I'm trying to get back into my career, and I might even have a possible interview coming up with IBM, possibly. That's only if I can pass what's called the CAT test, which is for those who may not know, it's a skill set that requires quantitative aptitude. So you have to kind of understand mathematics and stuff like that. So I'm not the greatest at that. So I've ordered a book on it by R.S. Agarwal that's going to basically help me on that, hopefully. Anyways, this video is going to be about more scrolling. I did promise you guys I'd put up a video showing you how to do an assembly fine scroll using, basically writing it in Mac 65 and showing you the assembly code for that. Now, I wasn't 100% entirely successful on this. However, I can show you what I've got as of right now and kind of the shell I'm working with. I've got it where it is fine scrolling. You can move the joystick. It's a joystick fine scroller. You can move the joystick in all alternative directions, and you will see the screen move in those directions. But it's not a fine scroll in the fact that it doesn't. It's still fine scrolling by line or pixel by pixel, but it doesn't look very effective when it scrolls. I think that's probably because I need to control the speed or something on it. But like I said, I haven't had a lot of time to play with that. But I'll show you what I got, and I'll kind of go over the code, and we'll see how it goes. First, I want to show you the first example here. I'm going to kind of swivel the camera around here a little bit. This is the first fine scroller I got, and I believe I had found this in it started with a basic program, guys, and I kind of converted it into an assembly program. So basically it was a scroller in basic where what it would do is whenever the program ran, it would just sit there and just keep scrolling the screen, and I found this online somewhere. But I mean, it would be moving so fast you couldn't see it, and these were actually just bars going down the screen here, so it looked like a bunch of bars moving real fast on the screen. So I took that code, which was in data statements, and converted it into assembly, and this is kind of what I got right now. I can kind of move it left and right here. And this isn't the final version, this is just the first one. And scratch on my monitor. And basically you can move it as it scrolls through the screen there. Notice the top line is not, actually it is scrolling here. It looks like, oh, when I move this line it doesn't seem to scroll this, but it seems to scroll it when I move back. So basically you see it's still scrolling though, and it doesn't scroll through memory. It kind of flips over if you hold it. You'll never notice it just flips back through memory. It changed a little bit there, and I think it'll flip back after a while here. I could set it up to scroll through memory, but I didn't want to do that. I just made it basically scroll backward and forward. So now let me show you the one that I've been working on, since this isn't the final part. I can show you the code for this one. I'm not going to explain this one, since the other one is comparatively very similar. So let me just show you the code. I'll show you the code for that just to be fair, for those who want to see it. I said the other one will look very similar to this, so I'll be able to explain it in the next one. There's a lot of explanations here on the side too for this one. These explanations, by the way, that you're seeing here on the side, these were taken from other various programs, and I kind of added them in, but a lot of this is my own explanations. Because the original program was, remember, it was written in BASIC, so there was really no assembly code for it where you could see the explanation. So that's the first one. And I'll run the second one, and then like I said, I'll explain that one. Let me see where this one's located at. I'll show you the code in a little bit. I just want to see where if it's in the same place. So I just type the number, and you can see that's where it's stored at F5FB4. So 5FB4. Notice this one looks a lot different. This one I've actually got a redefined character set, where the first one you just saw was just a regular character, which is known as an AXI character on the screen. Now you're looking at a redefined character, which is actually the brick character. And if you recall the other video, I showed you the basic to assembly scrolling maze. it used the same character, it's the same brick. And this one is just scrolling it in assembly. That one was in BASIC, so all I had to do was basically insert it into memory, and I used that random insert where it inserted everything into the bricks in memory. This one kind of does the same thing too. But it doesn't have the player missile graphic, it doesn't have the other plots for the characters. I haven't really added anything else to it, but it does scroll. Now the difference on this one is it'll still scroll, like here it'll scroll left and right. You see it scrolling there? It's going pretty fast for you to see there. Just notice that. But, and also the top window here. Oh, what happened to it? Let's go back to it. I think it's kicking out somewhere. You know, there's to assemble that again. Oh, it's trapped me on the screen now. Let's see. There's some kind of a jump out of the program. I have to fix that. It's basically, what it's doing is returning from a subroutine because I used what was called a pull from accumulator somewhere in the program, and that'll cause the program to jump out. I just need to fix that. But anyways, I wanted to show you it scrolls. It also scrolls, I was going to say, it scrolls vertically too. I wonder if that's the problem. I don't know. But as soon as I let the joystick go, it wants to jump back out. Well, I'm not going to move it this time. I'm just going to jump out again. I'll explain what I wanted to do here. I haven't worked on this one in a while, so I'm not going to mess with it. But when you scroll it vertically, basically, it kind of goes into memory problems. So basically, it'll start scrolling through memory at 250 increments, and I'll explain that in the program later. So it's jumping down 250 different places in memory. This one, when it's scrolling side to side, it's scrolling directly line after line. So it's, I think I had it set to 34000, just like I did the other program. And as it scrolls over the screen, it'll keep incrementing memory locations until it hits all the way over here, 250 increments out. But that's 250 pages, so it's not 250 bytes or 250 counts. It's 250 pages, basically, if I'm not mistaken on that. I might be wrong on that. But what it does is it increments in 250, and when you want to go down, you have to increment it down. You know, I'm saying this wrong. Actually, it increments one by one going this way. Increments 250 going down, since the limit it goes over to is 250. It can't go past that. But let me kind of show you. Like I said, I'll scroll it over here. Try not to make it stop this time. Oh yeah, I did add something in here. I just noticed that. It's right here. It doesn't jump out again. Let's see. Where is it at? Might be back here. I might have went too far. I'm scrolling through memory now, so what you're seeing is a weird looking, looks like it could be some kind of a game or something, like walls or something. Little level so they can climb up and down. So let me go back here. I added some other stuff in here somewhere. Where is it at? I went too far over. See how far it's scrolling over there? It is right there. I added this into it also. This little rock character in here is going to jump out again when I move it over. So let them reinitialize again. Now I'm going to show you the scrolling going up and down. Hopefully it doesn't crash, but you'll see it'll be scrolling through memory. It'll look really weird. I'm only going to scroll so far because it will start crashing. Now as I scroll up, oh, actually, you know what? I think it went too far over. Let's see. Oh, I should have moved it over first. I have to do it again. It's going to be crashing otherwise. Okay, so I'm going to move it over here. Seems to work better when I go over here. There it goes. Now you see it's jumping out again. Well, you can kind of see it on the screen now. It's scrolling through memory, and it's putting all these weird characters because it's looking just through memory locations in memory, and it's scrolling through whatever those areas are showing in memory. So let me go back and assemble it again. I gotta fix that jumping out. It's really bugging me. Okay, so let's see if I scroll it up. There it goes. That's what I was trying to show you. There it goes. Now you see it's kind of going through memory here. It might end up crashing, but we'll see. I'm trying not to get it to crash, but if it does, I'll just have to reboot the computer. Let's see. It did. It crashed. So let me reboot the disk here. Ready for this. Where's my disk? way. Here it is. Okay, so we'll load it back up. It crashed because it was going through memory, and it was also trying to poke into those memory locations for those who remember BASIC. And if it pokes into certain memory locations that it should be poking into, it's going to throw off stuff because it might be poking into an interrupt or something like that it shouldn't be doing. So I'll load the program back up, and this time I guess I'll just go through and explain it instead of crashing it again on here. Well, let me run it one more time. And just type here. Oops. Let's put the drive number. Usually that means you have to put the drive door down. You have to shut the drive door in the disk drive. That's what the error means. There we go. I guess everyone run it. What? And okay. So those who may not know, this is the Mac 65 screen you're still looking at. I haven't cleared it or anything, and it's not in a certain graphics mode. Look up here at the top, it even says Mac 65 version 101. And if you notice, every time the compiler starts up, it'll always have this at the top of the screen. So basically, it's just redefining the display list directly in graphics 0 here. That's all I did, is I made it just scroll it down. And then it's basically moving it through the display list in memory. And if you watch the other videos to scroll through the display list, you have to set bit 4. I think bit 4 is the vertical and bit 5 is the... Or bit 4 is the horizontal, bit 5 is the vertical. I forget which is which. But I'll explain that here in the program in a little bit. But that's how you basically get it to scroll and everything. I'm going to see if I can get it to do what I wanted to do this time without it crashing on me. So let's put it over here. Let's go down this time. And I knew it was going to do that. Well... Trying to show you something important here without losing it. Okay, that's what I wanted to kind of show you. It doesn't stay on the screen very long, but I guess you get the point. It's scrolling through memory and it's just looking really strange. So anyways, let me just get back to the program and explain that. That would only be fair, right? Okay. Now, it hasn't crashed on me. I can go and explain it again. So, there we go. I lost my pen again. Boy, I never can seem to have enough pens. I drop them all the time. Here it is. Okay. Straighten this out a little bit. It's pretty straight. Okay. So obviously, for those who may already know, Mac 65, this is required to appropriately assemble your program in memory, and it stores it in the object code so that it can run it appropriately. These are just comments in memory, so use the semicolon in front of it, and you can put comments in just like that. Okay, so let's go down here, past the comments. This is the, those who may not know, this is the counter. This is where it's going to store it in memory. And I've been showing this one in several other videos. But this Mapping Atari book is your best guide for understanding these memory locations. Just look up the memory location by memory location in the book. It won't be also, if you want to look up a memory location, it's not helpful going to the back here. I don't know if I showed this before, but let me get a focus here. See in the back where it says index by subject? These are not always helpful. I mean, you can find the memory locations, but they're not in any specific order. Rather, what they do here in the back is they look them up directly by the name of the memory locations and then maybe the name of what you're trying to find. Like this one says Playfield, Platt Pokey, and all that kind of stuff. So it's better just to go through the book. And if you look here, you'll see, I've showed this many times, but come on. Where is my pen at here? Oh, it's over here. Okay, so right here, this is the memory location right here. This is just the name. Boy, arm is getting so tired. This is the memory location. Come on. This is the name of the memory location, and this is the description and everything. So that's basically how that works. and this is just the hexadecimal number for this over here. So what I'm doing is I'm going to look up 24500 and show you. It's just a place in memory where you can store your assembly programs. It actually starts at a farther part, but I use 24500 because it says right here at the bottom of this page. It'll focus in a minute, I hope. Right there it says 13062. That's the end of dupe.sys, which is the DOS. The rest of RAM is available to location 32767. So as long as it's not running into your display list, you can use it. So I just basically use 24500, which falls in, to that range basically. So that's why I use that. So okay, let's see what we got here. These are the labels. So those who may not know in assembly, these are just whatever you want to name. And a lot of times when you're using the specific labels in the book I just showed you, you'll want to use that same label name. Like for example, H-scroll, if you look up 54276 in the book, I'll show this again, so kind of bear with me a minute, guys. 54276 right here. And there's a reason why I wanted to demonstrate this important point. Right there says 54276, and over there, well, I'm looking at the wrong one. I'm looking at 53276. 54276. 54276. Sorry for not being ready. It's the H scroll position. It's right here. As it focuses. Confident you, come on. 54276. And the label is just called H scroll. So this basically controls the horizontal scrolling. And use that label name. So if you look back in the program here, you'll see that's exactly what I did. I used H scroll and set it to that memory location. You can also use the hex value here if you want. And just type out the hex value here as you see me doing the screen earlier, and you can get the hex equivalent for it. I just like to use decimal because I'm more used to reading decimal. So that's what it does. It sets up all the labels. If you look at this right here, notice it says NVSRC E equals 176. Now set it to, this is basically setting it to a 0-page location. And then it says NVDEST equals NVSCRC plus 2. So what this is doing is it's taking this value location here, creating a new variable for it, looking for this one, which is, remember, up here, 176, and it's adding 2 to it. So this is going to be 178 because it already added 2 to this number. And if you look down here, it's kind of doing the same thing. It's setting a label called character address, or CHR-ADR. And it's just taking the previous one, which is right here, adding 2 to it. So remember, it's looking and it's incrementing these one by one, if you remember the incrementing videos. So this one would be 180. And this is kind of what it's doing. This is used for the character set. I won't be able to explain a lot of this because I didn't create the code for the redefined character set. It's just one I found online in the Atari assembly book. So I wanted to show you that though. So here's something I first do. Before I start this program, before I'm running it through memory, I'm going to clear memory locations so that we don't have a bunch of garbage in there and there's nothing left over whenever we're plotting random points or random walls in the maze, or whatever you want to call it, for the scrolling. That's what I'm doing, is I'm clearing the locations here. Now, I did this for simplicity for people who can understand, who may not been following my basic to assembly videos. I have several of those on there, because this will teach you how to convert bytes from low to high. And if you look at this, it says 208 plus 132 times 256, and it shows you the equation, the result. It's equal to 34000, and that's where we basically start memory at. Okay, and then you look here, it says load the cumulative number 208. Now look up here, it's got this by 208. Stored in 203, this is a 0-page location, so you want to use 0-page locations when you're storing values for high and low byte addressing, because you can't use anything past 256 page, or past 0 page 256 bytes out. It won't let you do that, so you always have to do them inside a 0 page. So what it does is it stores the low byte here, and you can see I put get low byte, stores it. So now location 203 equals 208. So if you type poke 203 or print peak 203, if you did that in BASIC, you would see this number 208 because it just stored it there. This one's doing, the next one in line is taking 132 and it's stored in 204. So remember, whenever you got one low byte, you're going to store the next one into the next high byte. If you look here, that's what this is doing. It's 208 plus 136 times 256 equals this value. So that's how it's getting the next high byte. Just know that whenever you want to store a number, like here, you want to use those bytes to find out what the calculated number is. And this is how I know it's going to store into 3400 because I calculated it from the low to the high byte and multiplied it by 256. So the accumulator will already do that. You don't have to multiply it by 256, it automatically does that. So just know that when you do that, these locations are now going to be pointing to this location. So what I'm doing next here is I'm setting up a load the X register loop so I can wipe out several pages here. So we basically got to clear all that scrolling. You see me all that way scrolling all the way over here. They're going to wipe out all that memories for as far as I have it scrolling over, so that there's nothing left on the screen, as I just explained earlier. So what this is doing is just taking a load the Y register. If you look here, I kind of explain it. Get the range, build start location. So this is where we're going to start because we're incrementing our Y. And we're going to clear memory. That's what we're doing. Load the accumulator 0. A 0 is a way to clear memory because it means it's off. And then we're going to store 203 comma Y. Here's where this low high byte actually works. Look right here. 203, remember earlier, was 208. So now it's looking at 208 plus 132 times 256. So it's starting right at 34000. And down here you notice it says increment Y. But keep in mind over here you see comma Y. It says begin fill. Keep going. So once you increment Y at 203 comma Y, this number will now be 209 plus 132 times 256, which is 34001. And then that's why increment Y keeps going through the loop here. It's going to go through all the pages in Y, which is set to 255 because it starts at 0 and it increments up the Y. It'll go up to 255 and it'll flip back to 0. So it's basically going through all these pages in memory. So this will be 34256 when I believe when this is done. And then it says if it's not, if the Y is not finished yet, go back to LPR and keep erasing in that area. Remember, this is only incrementing the first, which is called the low byte. And then down here you notice it says increment 204. Now go back here and you'll see 204, as you saw earlier, has 132 in it. Now if we increment a value, it's going to increment this number, which is now going to be equal to 133 because it incremented what was in 204. And remember earlier, if you print peak 204 in BASIC, you would see 132. But as soon as you increment 204 and use that register, it's going to increment the next value, which will be 133, 134, 135. So basically it's picking up the next high byte to keep accumulating this value to get a higher byte incremented and be able to, it's going through memory and it's wiping out all that stuff because it's going right through memory by memory. As soon as this value here, I wish I could show you another example, but as soon as this value becomes 255 plus 132 times 256, it won't keep going to 257, 258 because numbers don't go that high in assembly. It'll flip what's called the bit, the carry flag or whatever they call that, back to 0, and then this number will increase. Well, it'll only increase if you make it increase. If you don't make it increase, it'll keep doing the same 256 bytes. So this would only always say 34000 up to 34256 or 34255, whatever it would be. And then, however, once you've incremented that next area here, 133, now it's going to say 34257, 34258, because now it's incrementing on the high byte. So hopefully that didn't confuse people, that that's how it works. And then this just decrements the X register here. So it's just basically keeping track of X each time the high byte hits. So this X register will now be 22. And then notice it says here branch is not equal, go back to RST. So it's reflipping the Y. So it's flipping this one back to 0. If you can imagine this one being 0 plus 133 times 256, it's going to keep incrementing through that high byte. And then it's going to start incrementing this all over again. And that's how it flips through the next page in memory to get it to work. So if you don't understand that, get a book on assembly and start reading about high and low byte addressing work, and you'll probably follow that a little bit better. I'm not going to go into a huge explanation on that, but maybe I'll find another video that will do that. So let's go down here. We want to get on with this, right? Okay, so the next one here says fill with random wall characters. Now that we've already cleared the screen, the next thing we want to do is we want to start putting those wall characters you saw on the screen earlier when I was scrolling it. And this is, look at it's very similar to what you saw earlier. So 208, 203, 132, 204. So this is 34000, getting the low and the high byte. And this is I showed this example in my basic to assembly find scroller, or scrolling the map, scrolling the map. And this is what this does, is it's outputting random characters into memory, in places in memory there. And I ended them with 1, so it would pick the wall character, skip an increment, which is known as skipping an instruction, so basically like a timing, a delay or whatever, and then we're going to keep storing this into the 34000 up to the maximum loop, which again is 23. So it's basically going to fill, where earlier the first one wiped everything clean, the second one's now going to fill with the wall character. That's what that's doing. It's very similar to the one you just saw. The only difference is, instead of load equivalent to 0, you now got load 53770, and this is, if you look here, any random value. So this is picking random values every time. So basically that's just outputting them in random locations. So here's that pull I was telling you about earlier. This is the one I kept removing these because they kept crashing my program. So I need to find if there's more of them and probably remove them so it doesn't crash when I scroll it. Okay, so what this is doing now is, this is a program I found on the internet also that shows you how to scroll. The one you saw earlier in the first video, that's the one that I got this from the example. I just basically broke this down and got the assembly code for it, translated it into assembly for my own use. So what this is doing is it's just setting up the display list, 112, so it's basically setting these top lines here, and it's setting up these areas in memory as it's going through. It's building the display list basically. What it's doing is it's putting everything you saw on the screen when you saw the black lines going down like that. That's basically all it's doing, is it's incrementing here. And this is setting up the load memory scan plus graphics 0 plus the scroll. And this is used for the scrolling, so that you have to set up that what was it again? Graphics 0 scroll. I think this is the, well, this is for the horizontal and vertical scrolling, so it sets it all up right there. Puts it in this fuzz and kind of increments it. And this one down here is getting the screen memory. If you looked at earlier in my program save MSC, it's pointing to the lower byte screen memory, which is 88. It's getting this, what's in display that memory and storing that into the list basically. So kind of explain it. If you look at the comments here, you'll kind of maybe understand it a little bit. Remember, get memory address into the display list, keep the counter going, get the high byte, set up subtraction, make room for display in display list, counter is going, one line done, and it's basically how it keeps going until this is basically finished. This is getting the next lines down. The list starts way up here at the top, so the list -3 is actually way up here somewhere. This is basically covering the full range of the scrolling, so when you're scrolling you're getting all the top lines, not only the ones up to here. So, and this add with carry is necessary whenever you're scrolling through the display list and you need to jump over, what is that, the high byte page or whatever. Kind of hard to explain all this, but that's what this is doing, is it's allowing you to do the scroll through the left and the right increments. Okay, so this is checking to make sure that you've already incremented all the way through the end of the loop, and if you haven't, then we're going to go back to loop and keep doing it. This one down here is the jump, the vertical blank instruction, which is used in all the display list instructions. If you look at my display list video I have for there on I think it's a display list Atari basic or something, it'll show you how this works. So you have to basically jump from the vertical blank inside of your display list for it to be able to jump out of the display list without basically crashing, because it's basically keeping track of that horizontal scan beam. And this is how it jumps out of the loop basically. I know that's a mouthful, but I might have an example in here. Let me see if I have it in this book. I think I showed it in this one before. Actually, this is a pretty good one right here. But here, this is in... If you look at this right here, as it focuses, it says mode 0 display list. And you'll notice earlier you saw the 112, 112. Remember, those are the top lines, 66. That's the page it's going to jump to. These 2's are all represented in the graphic 0 output for graphic 0. The 65 is the jump vertical blank instruction I was just telling you about. The jump vertical scan or whatever, and these are the high and the low bytes we're going to jump to. And that's what this is doing, is it's allowing it to jump through the place in memory where I'm pointing it to. So we're pointing it to the areas in the high and the low bytes of this playlist so that it can correctly output the correct output while it's scrolling through the screen. So it's too complicated to really go and explain it all to you. But that's what it's doing, is if you kind of study that code a little bit more, this all wasn't my code, I did get some of this online, so that's why I kind of used the comments to kind of help people out a little bit there. These ones right here are just basically keeping track of you saw the little bar line going across the screen. I just drew that in, because earlier they ended up erasing the whole screen. I didn't want that, so I wanted to kind of make a little line later so it doesn't move or something, maybe like a score or something like that. But this is what this does, is basically filling in that top line. And these are actually filling in those little bars. You saw those little, what is it, blue characters on the screen earlier? That's what these are doing. They're filling them in those memory location areas. So, and this is the color, and this is another color right there. So I can just change the colors, because the defaults would be like orange and orange, blue, and green. So I changed them so that they look red and green or whatever I had them for. This is jumping right here to initialize, redefine the character set, so we can change the characters to make them look what we want to. And here's the scrolling routine. This one is just getting the high and the low byte of our vertical blank interrupt. So basically it's looking at this area in our code, and think of this as a high and a low byte number. So it's two different numbers it's going to get to put into the high low byte, so it knows where to jump to the vertical blank to set up that interrupt. This is what you always want to use when you set up a VBI in N65 and Max65. And then you would just basically jump. You don't want to jump back inside the VBI, so I just said jump to trap. So basically it means it's going to trap it and keep it on the same line. A trap in BASIC will keep a program in a certain area. So if you trap a certain line, it'll go back to that line if an error occurs. That's what that does. This saves the accumulator in the X registers, which is always necessary when you're using vertical blanks. You always have to save the X and the Y registers, or you're going to get a crash. And here we finally get into the joystick. So, now we're getting into some interesting stuff. You can see over here it's saying read stick. I put this for people who want to know about the basic part. Read stick 0, so it's going to read the regular joystick in port 1, or port 2, whichever one it is. And this is going to see if you are horizontally scrolling it to the right. So it says horizontal scroll to the right. So if you push it to the right, it's going to go to this label that's going to allow it scrolling to the right. If you push the scroll to the left, remember 11 is to the left, it's going to scroll it to the left. If you push the vertical scroll going down, so if you push the joystick going down, it's going to go to the label that's going to allow it to scroll down, and up, and so on. And this again is necessary, this last one, jump XITVB. It jumps out of the vertical blank interrupt, because if you don't jump out of it, what the loop will do later, I'll show you, it'll save all the values. Basically it restores the values from the stack that you had initially pushed onto the stack. Pulls them back off. I probably said that wrong. Pulls them back off so that you don't experience a crash. This is the horizontal find scroll for the right. So when you move the joystick to the right, it's going to get 8 bits per character, because you're always going to scroll 8 bits. Because if you look at each of these little characters here, there's actually 8. You count 8 high and 8 over. So it's scrolling 8 bits per character. So it's just basically allowing it to take that whole character and scroll it one by one. So it's supposed to be able to do it like a scroll like this, but apparently it's, because I don't have a delay in it, it's going super fast. So like I said, this is how far I got it, but this sets up for the next scroll, so it's incrementing. It's just a loop we created here, and it's just like, it's kind of like almost like a timing in a way, and it's incrementing through this loop, and then when it's done, it's going to output it to the scroll register so that you can see that scrolling happen. So as soon as you start scrolling all these bits, suddenly the scroll is going to take over and it's going to be able to start scrolling it. And this is for the right, this is for the left down here. Excuse me. This is the coarse scroll, because when you do a fine scroll, you have to do a fine scroll and a coarse scroll to get it to look right, even though mine still doesn't. So that's what this is doing next, is this coarse scrolling through the display list right here. It's going to get 4, which is the horizontal location in your display list. You always want to do this display list plus 4. And then it's add carry with 1 before addition, raise it by 1. In the display list, get the high byte and the low byte. This is basically how it's transferring in those values so that it can do the correct scrolling in memory. When you do an add with carry, you're basically getting the low and the high. So that's what this is setting up. I may have that backward, maybe the high and the low. High byte. That's probably the high and this is the low. And display list, move it forward, and display list 3 bytes. So this is allowing it to increment forward. So this is just allowing the move to happen. Compare it to see if it's equal 72. How far do you want to scroll it over? 24 times 3 equals 72. And keep in mind, this isn't controlling the screen scroll. This is just allowing the scroll to happen correctly. So if this were working correctly, you would see it moving very slowly once I got the delay set up. But for right now, this is what this is doing. You have to use the fine and the coarse scroll for it to work properly. So I tried to use delay in here, but it didn't work correctly because it kept crashing because when I use my delay, it uses the X and Y register, so it ends up crashing a lot. So I ended up taking it out and tried my own delay later. And once again, jump out of the loop when you're done with it. Jump from the exit vertical blank. Next thing we're going to do is we're going to check the left, which is very similar to the right, so it just kind of repeats everything here. And so this time it's going to scroll to left. So if you look up here earlier, we had increment. Now we're going to decrement because we're moving this way instead of this way. This is increment and this is decrement. So once again, once we're done, I also forgot to mention this. Once you're done scrolling, you want to reset the scroll register back to 7. Since you can't scroll past 7, there's not more than 0 to 7, which is actually 8. There's not more than 8 bits within the pixels of the characters, so that's how it scrolls. And this is just allowing the scroll to happen basically here. Just like I showed you earlier. Instead, earlier we did add the carry one, now we're just subtracting because we're moving it this way. Add, oops. So think of it as add, subtract. It makes sense because you're subtracting, you're going backward. You're going forward, you're adding it. So that's what that's doing. Once again, I try to get the delay, but it didn't work properly. This one goes down. So instead of using 54276, you're going to store it in 54277, which is the vertical scroll, which basically means allows it to go down. And once again, we're doing the fine and the coarse scroll here. So very similar to what you just saw earlier. Scroll the 7 bits, increment this until this goes back to 0. So it's basically saying 7, 6, 5, 4, 3, 2, 1, 0. And if it's not 0, it keeps going back here. But once it's 0, it drops down and resets it again. So same thing. Add with carry because we're going down. This one is adding down. So think of it as add, subtract when you're going down. Add, subtract. Hopefully that works because up is negative, positive is down. If you're going left and right, positive is right, and negative is left. That's always true. Okay, so next we're going to do the up position, very similar again, except this time, notice instead of putting this to 7, we put it at 0 because we're going to be scrolling up the screen. So we don't want to make it start at 7, we want to make it start at 0. And basically it does the reverse to go up. Because earlier the other one was incrementing, this one's decrementing. So if you're going backward, you want to start at 0, and then you decrement until this gets back to 0, basically. And actually this one doesn't look properly. I just now figured out why this is jumping ahead in memory. I never caught this before. This is not incrementing through 7 bytes, this is incrementing through 256. So I might need to make this say 7, and I think it'll work because if it decrements backward, it'll hit 0 and it'll flip it back correctly. So maybe we'll change that later and see if I can get that to work properly. Oh, funny, I was explaining it and I found it while I was doing my explanation. So This is the same thing too. It just stores the farthest +5, which is used for a vertical scroll, and add with carry because we're going up. Well, actually, I said subtract is up. I don't want to confuse you. And I just now realized I might have these reversed too. So, see, I'm discovering more things as I'm going through it here. I didn't notice that. Okay, anyways, enough of that. So this will exit out to the vertical blank, what I was telling you earlier. Every time you're done with these loops, you're always going to exit out and pull all the registers back off the stack so we don't crash them. Because earlier we pushed push TXA, we pushed TYA, and then we saved them onto the stack. Now we're just pulling them back off so the computer can use them again for whatever it needs it for, keyboard, clock, or whatever it decides to use them for. And this is just my own wait routine I try to do instead of a delay. I set up my own specific timer. I found this somewhere. I forget where I found this, in a program or something. Yeah, in a magazine, an analog magazine. And it shows you how to increment. This is a timer location in the Atari computer. And you wait until it hits the next increment or interval. Once it hits the next interval at 1, if it's not yet at 1, it's going to keep going back here, otherwise it's going to jump out. And I think this is why my loop is jumping out too, because this one didn't work properly. So I just need to exit these waits out, and that should fix that. Just remembering some stuff. Just down here, I won't explain it a whole lot, but this is the redefined character code to change the character set here. Just getting the high and the low bytes, storing them in, just like all those pages I showed you earlier, the 176 or whatever. It's just places where it can store the character set, which is 57344, and it moves it in memory. Because if you have to move the character set, and I need to get another video to really explain this, but you have to move the character set because it's stored in ROM, which you can't write over. Because if you were able to write it over, you'd be able to erase your characters. So instead, what the computer must do is move them in assembly to a place where you can erase it and then point to where that location is. So that's basically what that's doing. Like I said, it's moving. Here's where it does the move. It just finds the memory location where we stored those values up here, and it does the move here. Increments do it, so it's going to push those characters into a new place in memory. Not sure what this one's for, but like I said, this is not my code. This is just something I found on the internet. And then the main thing to look at here, this is also, oh, right here actually, I showed it 24578. So this is storing the RAM back in memory, so you want to calculate the RAM address so that you don't overwrite other things like player missile graphics or anything else that might be residing there. And this is how it increments by the values too. This is how you do an increment or a multiplication assembly. You do an ASLA, and it will multiply it by 2. An ASLA will multiply it by another 2, so that would be 4. This one would be 8. So that's just basically how you increment, or multiply an assembly, excuse me. And this is getting the new character set where you found the high and the low byte, because these were stored here earlier, so now it's storing them into the, I think this is the 756 location there. And this changes the character set. So here's how you redefine the character set once you're done with them. You find the label where this would be a bunch of bytes, and you draw them in like the data statement, so to speak, and it just draws them in memory here. This is saying that there's 24 bytes total in our character set here. So if you divide this by 8, it'll tell you how many characters there are. So that means there's 3 characters redefined in this program, because 3 divided by 24 is 8. So, alright, so this is my other delay. This is just a common delay. Here we go. Look down here. This is what you saw earlier up here was shape. So basically it takes the shape and it counts here in memory. So there'll be 24 of these total. There's an 8 to each line. And these are just one character. This is another character, and this is another character. I think this might be the wall character, and this is that little block flip character you saw earlier. I was going to use the other one for other stuff, but that's basically what it is. So let's go back and fix that other stuff I was talking about earlier. Now that I noticed why it may not be scrolling properly down in memory. So I'm going to look for that location here. So what we're doing is we're going to look for the one that's scrolling, well, scrolling down and up. Those are kind of jumping out of a sync from where they should be sitting. up. So, where was it at? I see the fine scroll. Maybe it was the down scroll. Let me go back here. Alright, so let's see. This one's cracked, so it sets it to 7. 7. Or scroll. It's this one right here. Yeah, it's starting at 0, so this needs to start at 7 because it's decrement. It's back to 7 because it resets it to, I put 7, this will probably be 0. I think that's probably why this doesn't look right. Okay, so let's try to scroll it up this time and see if it works. Because earlier the scroll didn't work when we go up. I might even need to save this, it might crash, but we'll see. Oh, and we also need to remove that weight because it's causing the program to jump out. So, scroll over here. Scroll up. Nope. Down works, but up does not. Okay, so let's find all those occurrences of weight. See if there's any of them in there. Might not be though. Let me see if there was. There's not. Okay, so I'm not using weight. I guess I'm just using delay. For the weight. There's one. Let's turn that one off. Since they don't work properly, I'm just turning them off. There's the other one. I think that'll prevent the program from crashing when we scroll it now. Hopefully. Find out. Yep, it's not. Doesn't appear to be crashing now because the delays was reset in the registers and it was thrown off the program. So looks like it's fine now. So it's allowing me to scroll in both directions, as you can see. Like I said, the scroll is going super fast here because it's doing a coarse scroll. It's just not doing a proper fine scroll. It is really doing a fine scroll because it's moving so the screen's moving so fast. It doesn't look like a fine scroll. So if I was trying to figure out how to slow this down, if I figure out how to slow this down, it'll look a lot better. But I mean, it's still a scroll. You can still see that it's moving and it's written in assembly, which was my goal. So let's see if what the downward does now. I'm curious. There it goes. Look at that. Isn't that kind of weird? So scrolling through memory right now. I don't know what that is. So oh, it's going through my memory location. So this must be found where the lines are. So I'll bet right now it's probably overwriting my program, but I'm just curious to see what's going to happen. I'll keep going. Let's see. These always get me curious. Watch how cute this is. Watch how neat this will look. Good to see it doing some weird scrolling. Look at that. Val instruction location. Isn't that interesting? This stuff you can kind of see in memory when you start scrolling through memory. And you're seeing it output to the screen real time here. Transfer save, I don't know what that's for. Read. But you can almost see what it's doing. It might be part of the Max65 code or something. Let's see. I have no idea where it's at in memory right now. I'm just scrolling through 250 increments each time, so it could be anywhere. Look at that. Weird, isn't it? Eventually you won't see anything is what'll happen. It'll crash if I hit it go again. This is kind of weird. I mean, this is some weird looking stuff here. That looks like one we seen earlier. When we saw that first program, these were the redefined characters, so this is that little act character, what do you want to call it. So, and that may have been the place where it was scrolling earlier too, who knows, it might be looking at that memory area. So here you see some, let's see what this is, address. I'm always just curious to look at it, because you can sometimes see stuff. Eventually, look here, the Atari computers, isn't that interesting? These are messages that are stored in your computer, so somewhere in your computer you have the Atari computers. I think this might be getting to the, what's that called, the memory check or whatever, from the self-test. It's got all the, or it might even be DOS, it might be reading DOS declaration somewhere. Completed, look at that, at completed, so it's like 100% complete or something. Isn't that interesting? Back to BB. That's why I think these kind of programs are really cool. You can start seeing, look at this. Get high byte, at carry, Z, increment Z. I don't know what that is. Clear increment range. Oh, this is interesting. I hope that I can come across some of the higher ROM locations. You can start seeing some weird stuff when we get over there. What we're scrolling through memory. I know we kind of went off subject from the original program, but I just thought this would be interesting just to show you what it looks like when you scroll through memory. People might get a kick out of this, hopefully. You're kind of seeing what the computer's looking at, and this is looking at all locations in memory from 0 up to 65 by 35. And just jumping through 250 increments each time. I just saw a delay edit. Looks like it's getting into the max 65 there. It might be even flipping it too somewhere. Let's see if stuff starts looking similar to what we saw earlier. See these things changing right there? Those are actual ROM locations. So this might be a timer or a random counter changing in increments. So you're seeing it real time happening. I like it when you get into ROM because you'll see the whole screen kind of animated. It'll start showing the stuff all over the place. I was seeing if I could find that area without crashing the program. I'm sure it's probably crashed already though. Let's see. Look at that. That is really weird. Counter is going. Oh, so it's picking up. This is where it was storing part of my code here. If you look here, it says counter is going. That's what I wrote earlier in my my comments. So this might be what a comments are storing or something. And this is just how you're looking at it and how the computer compiles it and everything. Let's see also. Let's see Atari over there. Really, really bizarre. So you can get some really cool stuff when you really start looking at memory. And having it display this on the screen makes it look a little bit more fancy anyway. I don't know what this is. Hopefully we can, there they go. That's what I was trying to show you. See these things changing, they hear like animation going on. These are probably up somewhere further in memory, probably at 54000 or something like that. And it's basically showing what's going on real time in your computer. So there's counters going on inside your computer that are moving and incrementing. There's the random 53770 increments, and you see stuff changing in memory. So you're looking at memory real time now. You saw some of the examples earlier when I was scrolling through it. Maybe we'll find other stuff if we keep going through here. Sorry I got off track here, but I got carried away with this one. But I did explain the code, so we'll kind of end it with this maybe. See what else we can kind of find here. Set counter. I don't know what that is. Yeah, parts of my program again, I guess. Kind of weird when you look at it, isn't it? I know it's probably crashed by now. It might be flipping over. This looks very similar. See if I can slow it down a little bit. Maybe I can find something else. Because I'm jumping in 250 increments. So I might be skipping over stuff. Looks like, look at that, JSR delay, so it's pointing at where my code, part of my code might be stored. I'm pretty sure it's erased my program by now. Now see if I scroll this way, it'll still move that way, but it's going to increment in 1 byte by 1 byte. I think that's what I needed to do. Let's do it that way. It's so fancy looking. I can't get over how it looks. It's really cool to see memory scrolling. I always get a kick out of seeing memory scroll. If I go like that, you'll see it move really fast. I didn't want to go too fast for you not to be able to see it. Let's see if we can find other stuff in here. I usually make these an hour, so you only got a few more minutes to bear with this unbearable scrolling, if you will. Go back this way. We just go back that way. Go this way. Go that. See the top moving down there? I can tell we're scrolling still. So. That is just really weird. Hey, look, we're back where we started. I thought we were. Looks like a little game or something, doesn't it? It's kind of cool looking. I guess somebody could be jumping up a level or something. This is cool about redefining characters and scrolling through them that way. Sometimes you can get interesting pictures to show up on the screen. It's a pretty cool scroller, don't you think? Look at that. Another line done. Where have I seen that? Another line done. Oh, this is in my code again. This is picking up parts of the comments of the code. Safe escape. I don't know what that means. That must be in the code too somewhere. Maybe that's the line number over there or something. Now it's changing colors on my computer. I have to turn it off. And we're back to the character set again. Oh, there it is. That's it. So that was that 3400 right there. Right there. That's a cool looking picture, ain't it? It's like a giant castle or something on a wall or something. I just thought you might get a thought that was interesting. Let's see if I can find what I wanted to show you. What's that say? Into the display this. This is probably just more of our code. I hold it over here for a while. I might get to something really interesting. Look at that. There's a bunch of lines, it looks like. See, we're scrolling through regular increments now. We're not jumping in 250 increments. But if I move it down, it'll go back to what it was earlier. You're going to see different stuff now because I'm at different pages of memory than where I previously was at. Now I might be in the ROM area. I haven't seen it changing yet. I don't know where I am. Eventually it'll just crash altogether. It'll stop. Might have just did that. I think I just exceeded the areas of memory. Now it's not doing anything now. Let's see if I reset it. Yeah, it's gone. Okay, anyways, that's enough of that program, but I just thought, you know, you might be interested in checking out scrolling, stuff like that. Memory scrollers are really cool, as you just seen, the kind of stuff you can do, especially when you're doing an assembly, because in BASIC it would be a lot slower when you move the screen over. It kind of real shaky and real jerky when it starts scrolling everything over. It doesn't look really good, so just putting my Atari disc back in here. So I just thought, you know, I would show you that and just kind of explain the code and everything and see what you guys think of that. I don't have a lot of time to really work on it now. I'm going to be working with a friend on an ASP.NET project because so I'm trying to get back into IT field and need some kind of experience to do that. So I had a tough time since graduated from college last year. Like nobody wants to take a new recruit from college and move them into their company. So anyways, this is what this was about. It was a scroller, so I hope you enjoyed it, and I'll try to get some more Atari videos out there eventually once I start catching up to some of the other things. So thank you for watching, guys.